Properly mending the assembled corner of any IG unit is a key element to the longevity and durability of that unit. The purpose of the vent hole in an intercept IG unit is to allow the air pressure to equalize during the oven pressing process and to facilitate the addition of thermally improving gas such as argon or krypton. Before getting started, there are a number of considerations to be aware of. The formed and folded intercept spacer must be manufactured to the standards set by GED document ES0008, Intercept Frame Machine Finished Spacer Quality Specifications. Particular attention should be paid to the tab swedge and cutoff locations detailed within this document. See the video on intercept spacer folding techniques for folding and handling suggestions and demonstration. In addition, you may view the Vitro Intercept Spacer System Quality Assurance Manual on their website. The sealant applied to the bottom and side of the spacer must start prior to the end of the tab by about 1/4 to 3/8 of an inch. This sealant material on the tab is tucked into the fourth corner during assembly, which provides sufficient sealant material needed to mend and seal the corner after the tab insertion. The extruder operator should examine the spacer end to verify the sealant application. Side sealant must continue all the way to the end of the spacer. The last portion of the bottom sealant is needed to support the mended joint. The tab should be fully inserted so the holes are properly aligned. Misalignment of the spacer holes may be repaired by the worker removing the hot units from the oven. Using a pointed tool such as an awl, the worker can gently pull the holes into alignment while the material is still hot. The sides of the tab should be under the side lips. If the tab is inserted at an angle, tab sides may not insert under the lip, creating a large gap on the back of the spacer and excessive corner flare. Once the tab is fully inserted, the operator should gently press the back material to mend the ends together, and press the material into the seam while it is still hot. Do not press too hard or wipe the material, as this may leave the metal exposed. With regards to the patch sealant, consider the sealant thickness. It should be enough to fully cover the fastener with no air voids or exposed metal. Typically, the sealant should fully fill the spacer undercut from the back of the spacer to the outer edge of the glass. Ensure that the patch sealant is at the recommended application temperature. Depending upon the type of patch pump, it may take 30 to 90 minutes to warm up and stabilize temperatures. The temperature of the sealant used to patch the fourth corner must be high enough to remelt the sealant on the IG unit to create a bond between the two materials and to the glass and spacer materials. Consult the sealant manufacturer for specific process parameters. Many of these materials and their manufacturer's recommended extrusion, oven, and patch pump temperatures are listed in GED document APN 0189. Do not use sealant gathered from other sources other than the dispensing gun, such as from the pump bleeder or platen. This material will not be hot enough to remelt the sealant on the IG unit and can also easily be contaminated with dust or other debris. It is best to use a brass nozzle tip like these shown here, made by GED. Tips of this style typically come in various sizes to accommodate different width IG units. This type of tip allows material to be applied under pressure, which reduces the chances of voids and ensures a better bond. Use a silicone pad to smooth the hot applied patch sealant material to the vent hole area. Do not use a stick, spacer, or glove to smear the material into the vent hole area. These items will quickly conduct heat away from the sealant and result in the sealant not being hot enough to weld to the existing sealant. Do not smooth the main bottom sealant material into the vent hole area. Do not push and pull the patch sealant to make it look good. Before applying patch sealant to an IG unit, it may be necessary to squirt a small amount, approximately 2 ounces, of sealant from the gun into a waste container in order to move the hot material from the heated portion of the gun to the application tip. If applying patch sealant and smoothing it afterwards, be sure to patch no more than 4 to 5 units at a time. The sealant temperature will become too cold if the IG units are processed in large batches. Using different colored patch materials can help identify voids between the materials. It is sometimes possible to use a hot melt patch material over moisture-curing warm applied sealants. Check with the sealant manufacturers for compatibility of specific materials when using different primary seal and patch materials. Prior to patching, ensure that the units have cooled down to ambient or room temperature. Sealing a unit that is too warm will create a negative pressure inside the unit as it cools, concaving the glass and deflecting it inwards towards the middle of the unit. This puts a constant stress on the glass and may result in a thermal stress crack, which will typically originate at a chip or other glass edge defect. The assembly hole is typically secured with a mechanical fastener, such as a screw, rivet, or scrivet. A scrivet is a GED fastener specially designed for intercept spacer, which inserts like a screw but has a low-profile head like a rivet. Units made with a moisture-curing sealant may use an adhesive foil disc to cover the hole. The fastener needs to be installed perpendicular to the surface of the spacer. A fastener that does not lay flat against the spacer may indicate poor hole alignment or assembly technique. This will often create an air void around the fastener. Ensure that there is no debris or contamination that can become trapped underneath the patch sealant. Begin by purging some material at the tip to ensure the material is flowing freely with no lumps and the material at the tip is hot. This should be done anytime the handgun sits idle for more than a few minutes. Immediately begin applying hot sealant to the IG unit by placing the nozzle tip on the unit about 2 inches before any bare metal, pulling the trigger, and slowly moving the gun towards the corner. If the tab is a standard tab, continue the patch around the corner slightly, 1 to 2 inches. Trial and error adjustments of the pump and gun flow characteristics will help the operator properly pace their movements. Proper directional movements and pace will help minimize sealant voids. There should be no spacer or fastener exposed. The key is to let the material push out from the front of the tip slightly and draw the bead towards the corner. Pulling the bead and moving too fast will leave voids. While patching 1 unit at a time is best, never exceed 4 to 5 units at a time, as the material cools too quickly, resulting in a cold patch. Before the patch sealant has a chance to cool, the sealant must be pressed into the patch area. Using a silicone pad between the patch and the index finger, apply pressure to trowel the hot patch into the valley between the 2 lights of glass and around the corner. The goal is to completely fill the patch area so there are no air voids between the glass, spacer, fastener, and sealant. Care must be taken not to remove sealant from the corner or area over the fastener by wiping the sealant to make it look attractive. Do not push and pull the patch sealant to make it look good. Visually verify that there is no exposed spacer or fastener material. Also verify that there is no excessive sealant material on the outside of the glass, which can interfere with the glazing operation. While some may deem it necessary to use capillary tubes, they're not recommended by Vitro or GED. For more information on the use of capillary tubes, please refer to the FGIA document IGMA TB-1601-95. To review, key characteristics of a good fourth corner patch include: the sealant extends to the corner with a corner plus tab, or wraps around the corner with the standard tab. The sealant extends beyond the vent hole. The sealant fully contacts the glass on both sides. The fastener is completely covered. There are no gaps or trapped air pockets. Sealant is not present on the outside of the IG unit. There is no exposed metal. No debris or contamination is trapped underneath the patch sealant.